Adventurous kids explore with education and learning what a wild life is in the Everglades. I want to explore the Museum of Discovering Science. What plants do butterflies like? I want to know about Key West Adventurous Kids. Learning and fun. Adventurous Kids!
Today, I'm going to tell you about the double-slit experiment. So, to understand the double-slit experiment, one of the things we have to qualify first is that there are two different types of physics. Physics is how we interact with the world. So there's Newtonian physics, and that's the physics that we deal with every day, right? That uses gravity, is sort of what we interact with. And then there's quantum physics, that's physics on the subatomic level. And the double-slit experiment deals with quantum physics, right? When we break things down to the subatomic level, they can behave like particles or they can behave like a wave, right? So you can think of it as the difference between like this chair is solid or water and liquids that, kind of have this disruptive pattern. So the double-slit experiment is a way to look at light because light is intriguing to physicists for the reason of it behaves as both a particle and a wave depending on how it's being observed, which is really cool. We haven't seen that, right? So when we look at particles and how they behave in the natural world, they can stack neatly, again, this chair, or they can behave like a wave, how we think of liquids. Light behaves as both a particle and a wave depending on how it's being observed. So the double-slit experiment wants you to consider two walls. In the first wall, there are two slits, just a so holes to go through, and on the back wall is solid. Now imagine on the back wall is solid. Scientists shine a light through the first wall where light passes through the slits and examines how it behaves on that back wall, which when observed first looks like a wave, but then on a subatomic level, when we're looking at the photons, which is what we call a light particle, they start to stack neatly, which would seem to go against observing them as a wave, right? So you can think of it like this. If you had two walls, just like I described before, two slits in the first one, solid in the back, and let's say you are throwing tennis balls, right? You can think of those as the photons, and you can think of them as being covered in paint so that they'll leave a mark on the wall once you throw them. So once you throw these balls and you're kind of just rapidly throwing them through, you're going to see that they're going to pass through the hole and leave a mark that's just kind of either in a line like this, following the shape of the slit that they passed through, or they're going to stack neatly on top of each other if perhaps one goes through at the exact same place, right? Versus when we see it behaving like a wave, now instead of tennis balls, take water. And again, you can dye the water so that you can see the mark that it leaves, and you rush a bunch of water through that wall. So the tennis balls leave those neatly stacked imprints, the water's going to leave a wave. It's going to leave more of a wave is the only way I know how to explain it, right? Just like a gradient on that back wall. So why is this experiment important? Well, it shows that on the subatomic level, light is sort of switching the way that it behaves. It sort of exists in two states at the same time. It is both a particle, photon, and a wave. So one of the things that we realized is that even when we start observing the light in one way, right, with just our eyes, and then we switch to the subatomic level, in the middle of us going from observing it this way to observing it this way, the particles change from acting as a wave to acting as a particle, and then again, if you go back to the other way observed, acting like a wave. So it's changing based on how we are interacting with the photon. So in quantum mechanics, this is called a wave-particle duality, and this observation plays a big role in how we understand quantum systems. So the double-slit experiment shows us just how strange and wonderful our world is, even on the subatomic level. Thank you for watching this episode of Adventurous Kids.
What did you learn today?
Adventurous Kids!
Adventurous Kids!
What was the most interesting fact?
Adventurous Kids!
Adventurous Kids.
Adventurous Kids.